In these problems, we are going to factor rational exponents. So I want you to think about the rules that we used when we were factoring by GCF. So when you're factoring by GCF, you're looking for what do they have in common. Well, the number 2 and the number 5 don't have anything in common. But I do need to take out the smallest exponent. Okay, by removing the smallest exponent, that will be the largest thing that they have in common. So in this problem, the smallest exponent is the x to the negative 1/3. So what I'm going to do is I'm going to say that that is the GCF. And when you take out a GCF, what you're really doing is you are dividing it from its original, meaning top exponent minus bottom exponent. So in that case, this would cancel from the first one and I'd be left with just a 2. For the second term, I'm going to subtract, I'm going to do 4/3, which is the top exponent. And I'm going to do 4/3 minus negative 1/3. So what happens here? It becomes 4/3 plus 1/3, which ultimately is 5/3. Oops, let me erase that. 5/3. So then I end up with 5x to the 5/3. So this would be my final answer. Notice it looks like a distribution problem, as it should, because if I distribute it back, I should get back to the original. But remember, factoring is the opposite of distributing, right? It's the opposite of multiplication. We are in fact dividing, which again means we are subtracting the exponents. So let's look at the second example. In the second example, the 2/9 is the smaller exponent. So that's going to be my GCF this time. So when I divide out the 2/9 from the first term, obviously that leaves me with just a 1 because they cancel. And when I do it with the second one, it becomes minus x to the 5/9. Because 7 minus 2 is 5. Let's look at one more example. This time there's 3 terms, but again, it doesn't really matter. I'm always looking for the smallest exponent. And in this problem, the negative 2/5 is the smallest. So my GCF this time is going to be x to the negative 2/5. And again, that's my GCF. So that is what's getting divided out of each term. If it's helpful to write it out so you can really see how it's the top exponent minus the bottom one. So for that first one, when I do negative 2/5 minus negative 2/5, they actually end up canceling to 0. And we know anything to the power of 0 is 1. So that leaves me with just the 1/2. Cool. Next, I know it's going to be plus 3, but I still have to do the top exponent, which is 3/5, minus the bottom exponent, which is negative 2/5. Again, that minus creates a positive. And everything's just simplifying down. 5/5 is equivalent to 1, so I can just have x to the first power. And last but not least, I know it's going to be negative 1/7, but I still have to do the top exponent minus the bottom exponent. That minus again creates a plus, which leaves me with a positive 1/5. So here I'm going to have negative 1/7 x to the 1/5.